This is Note-Taking Guide 5.5, Graphing Exponential Functions. Now, exponential functions are a little bit different than what we've been graphing because they don't really follow a pattern. So I just want to take a couple of seconds and just review a way that we can graph something without knowing a pattern. That would be called a t-table. We would want to find a t-table and we would graph some ordered pairs from our t-table. So a couple of things to notice about this function is that it kind of approaches a line that it never crosses. It's called an asymptote. And it grows really, really fast, or it comes down really, really fast. That's why it's called an exponential function. The domain and range of exponential functions are from negative infinity to infinity, meaning all the way to the left they go forever, all the way to the right they go forever. And the range, this little guy here, he's bounded at 0. He doesn't get to cross the 0, but he goes up forever. Same thing if we have the exponential function with a number less than 1 here. The only difference is that it starts up high and comes down low. Domain is still negative infinity to infinity, meaning forever to the left, forever to the right. And range is still bounded by 0 and goes to infinity. So what we're going to do here is I'm just going to teach you how to do a t-table to graph these and see if we can find some patterns as we go along. So I like to put 0 in because it kind of turns out really nice. If I do 4 times 2 to the 0 power, because I'm just substituting it in right there in place of the x, 2 to the 0 power is 1, and 1 times 4 is 4. Then I'm going to put in the number 1. So I'd have 4 times 2 to the first power. Well, that's 2, and 2 times 4 is 8. Then I'm going to put in negative 1. So 4 times 2 to the negative 1 power. 2 to the negative 1 power is 1 half. 1 half times 4 is 2. So then I'm just going to graph those ordered pairs. If you notice, the graph paper kind of got messed up down here, so kind of just take a look at it and finish it the best you can. So you're over 0, you're up 4. You're over 1, you're up 8. And you're over negative 1, and you're up at 2. So that's probably enough to know where our graph's going, because we know it's going to be bound by 0. So we know it's getting closer and closer to 0, but it's not going to cross that x-axis. Now, something I do want to point out to you, so when we start going backwards, you'll notice, is if we look at where 0 is on our t-table, that number or that value also appears in our formula. And then I want you to notice something else too. If I look at two ordered pairs that are next to each other, like 0 and 1 are on the number line next to each other, if I look at their y values, I can see what I multiply by from 4 to get to 8. When I did that, I multiplied by 2. And I just want you to notice that that 2 shows up over here in the equation. So we're going to try to show you some hints as we go, and that's just a good thing to remember as we're going along here. Okay, we're going to do another set of values here. Again, I like to start with 0. So I'm going to do 4 times 1 half to the 0 power. 1 half to the 0 power is 1, and 1 times 4 is 4. I'm going to pick 1 again because I like to do 1. So 4 times 1 half to the first power. 1 half to the first power is 1 half, and 1 half of 4 is 2. Then I'm going to put negative 1 in. And if you're not seeing where these negative 1 things are happening, make sure you use your calculator because they're a little bit confusing. But if you remember, the negative 1 as a power flips this upside down or changes the negative to the bottom. So this would really be 2. So 2 to the times 4 would be 8. So I'm over 0 and I'm up 4. I'm over 1 and I'm up 2. And when I'm at negative 1, I'm up at 8. Again, the graph paper is kind of messed up here, so just do your best. But we know we're coming down like this. We're going to approach 0 without crossing it. Now again, just a little point to be made that if you look at the 0 x value, its y value shows up over here in your formula. And if you're trying to figure out what you multiplied to get from 4 to 2, then we multiplied by 1 half, which is right here in my equation. So that's going to help us when we're moving the opposite direction in just a minute and we're doing our equations. Okay, here's another one. Let's just pick some values. I'm going to put 0 in. So I'll have 1/2 times 3 to the 0 power. 3 to the 0 is 1. 1 times 1/2 is 1/2. I'm going to put 1 in. So 1/2 times 3 to the 1. This would be 3. 3 times 1/2 is 3/2. I'm going to put in a bigger number, I think this time, like -2, just to see what's happening there. So I'll have 1/2 times 3 to the -2. 3 to the -2 is 1/9. So 1/2 times 1/9 is 1/18. Now this doesn't look like it's going to give me a very good idea of where I'm going, because if I'm 0 and I'm up 1/2, and I'm over at 1 and I'm up 3/2, and then I'm over at -2 and I'm barely off, it's really hard to see what I'm doing. But knowing what exponential functions look like, I know that I'm going to be growing up over here like this rather quickly, so I have a good idea of where to sketch. Again, just to make the point, the 1/2 that's next to the 0 here always shows up in the equation. And then if I wanted to figure out what I multiplied by to get from, and just remember these points have to be next to each other in the counting number line here. What did I multiply 1/2 by to get to 3/2? Well, I multiplied by 3. All right, one more last example of this, how we're going to graph these. I'm going to put 0 in again, so I'll have 5 times 1/2 to the 0 power. 1/2 to the 0 power is 1. 1 times 5 is 5. I'm going to put in 2 this time just to see what happens. When I put in 2, I'd have 5 times 1/2 to the 2nd power. 1/2 to the 2nd power is 1/4, and 1/4 times 5 is 5/4. And then let's put in -2. So I'll have 5 times 1/2 to the -2. 1/2 to the -2 power would be 4, and 4 times 5 would be 20. So my ordered pairs are 0, 5, 2, and 1.25 about, and -2, 20. Which gives me a pretty good idea of how to sketch my graph. I know I'm bounded right here because I didn't have anything added or subtracted to my equation up here. So again, point to be made, the 5 is there. And this is a little bit different because I went more than one value here. So what did I multiply 5 by to get to 5/4? Well, if you notice here, this skipped 2 values. So I'd have to remember to skip 2 values here. So I multiplied by 1/4, but 1/4, how did I get 1/4? It would have been 1/2 times 1/2 for those 2 values there. Okay, we're going to go backwards now and see if we can write our equation. So just from what I showed you a second ago, let's just look at the 0 value. We know that at the 0 value we're equal to 1, which tells me the number that's out in front is 1, because that's what I showed you over and over again on this other side, that at the 0 value the number that was out in front was 1. Then I looked to see what I multiplied by to get from 0 to 1 on my y values. So if I come back over here and I look at this, what did I multiply by to get from 1 to 3? Well, I multiplied by 3, so that's my number that's going to be raised to the x. Then I like to just try it to make sure it works. So let's plug this 2 in and see if it works. 3 squared is 9. 9 times 1 is 9. So that checks out and I'm good to go. Okay, this last one again, the number that's next to the 0 is going to be my equation I'm multiplying by here. And then how did I get from 10 to 50? I multiplied by 5, so it's 5 to the x. Plug in the 2 to make sure it works.